All right, science family, we've been learning about a lot of different things about matter. Something that's important is understanding the difference between molecules and formula units. By that, I mean bonds and compounds that form from covalent bonds. We call the smallest little particle made from a covalent bond, we call that a molecule. Anything that's a formula unit is basically the smallest whole entire thing made from ionic compounds. We call those formula units. We know a lot of people use the word molecule loosely to mean everything that's a compound, but actually things formed from covalent bonds, they're called molecules, and things from ionic compounds are called formula units. So right in front of me here I have sugar and salt. Now, something we've learned about is that a property of ionic compounds is that it's called an electrolyte. But what does that mean? Where does that come from? Well, let's explain that through this quick demo. So first thing is I have some just pure water here, and I'm gonna fill both beakers up here so that you see. It's just simple water. Now what I'm going to do is I'm going to take my salt. Remember, salt is made of sodium and chloride, a metal and a nonmetal, so that means that it's an ionic compound. Remember, the smallest piece of an ionic compound that still has its properties, we call that a formula unit, when one sodium and one chlorine ion come together. So the first thing I'm going to do is I'm going to take my salt, and I'm going to dump it in my water, and I'm going to take my glass stirring rod, and I'm going to dissolve that salt into the water. All right, I'll let that sit. Now I'm going to take my white sugar. I'm going to take it in my empty beaker that just has water in it, and I'm going to add that sugar to the water, and I'm going to stir. Now we're learning that ionic compounds, one of its properties is that we call them electrolytes. Now you've heard of electrolytes before, maybe like in Gatorade or sports drinks. Yes, we need different types of salts in our body when we're rehydrating ourselves because those ions can help with proper muscle function. Potassium's important, sodium's important, calcium's important. In fact, if you get into biochemistry more, you're going to learn more and more about why salts are important for the body, especially for athletes that are playing like all day, like a long tournament in volleyball or a super long cross-country run, or even if you're running a marathon. Those are super important. So what I have here is an apparatus. It has a light bulb with a positive and negative end, and what you can't see is that I have it plugged into the wall. The thing is that the light bulb isn't lighting up yet, okay? But there is electricity going through it, but nothing's completed the circuit for the light bulb to light up. So what I'm going to do is this. I'm going to place this light bulb inside the sugar water to start. If the sugar water conducts electricity, this light bulb will go on. So let's see if that happens. No, nothing happens. All right, so an explanation for that is sugar, which are covalent compounds, right? It's a molecule. When they dissolve in water, they really don't break apart into positive and negative ions, so therefore, they're not electrolytes. They don't conduct electricity. Again, think of the word electrolytes and electricity. There's a similarity there and a relationship. All right, now I've got my salt water. Let's see if we put this into the salt water, if it'll conduct electricity. And lo and behold, it does. Can you see that? When I put the light bulb electrodes in the salt water, it conducts electricity. So what's happening here? Well, when we dissolve the salt into the water, it started breaking up into its positive and negative ions. Positive sodium ions and negative chlorine ions, technically called chloride. By doing so, there are positive and negatives in this water, and when we put the electricity through it, the electricity can pass from one electrode to the other to complete the circuit so the light bulb can light up. So when we think about properties of ionic compounds, we say that they tend to be electrolytes, meaning they often can dissolve in water, and when they do, they conduct electricity. Unlike molecular compounds, which have covalent bonds. These guys don't break down enough, and they can't create that positive and negative end that can conduct electricity. So from there, I hope this demo helped you better understand a little bit about the difference between molecules and formula units, or covalent compounds and ionic compounds, and also the reason why ionic compounds are called electrolytes. They conduct electricity when dissolved in water. All right, Science fam, thanks for listening. Hopefully this just ties a few ideas together back to your real life, and you learn and understand a little bit more about life in general. Take care.